Okay, so now that you guys have learned how to use the torch here, I'm going to show you how to anneal a piece of metal. And annealing is, I think, the secret to all metalsmithing. If you can learn to anneal metal properly, you can put it in any form you want to put it in the way of hammering or shaping it or forming it or embossing. Annealing is at 1200 degrees Fahrenheit, and that's true about all the metals. The metals that are a little bit more finicky are silver and gold, because copper, you can almost heat it up to its melting point and it still stays soft. But silver, if you get it up over about 1450, it becomes hard again. So you need to start out learning how to anneal with copper and brass and bronze. And then as you become more comfortable, we'll be working with the silver. So I wanted to start out today with the copper, because copper conducts heat really well and it shows the heat pattern. And I think it's a really lovely thing for people to watch happen. So I'm going to open up my gas. I'm going to light my torch. Maybe. No, I know why. I have to turn these on. I don't usually turn them off. There we go. So when you can't light your torch, check and make sure you've opened up your valves. Okay. So I got it just a teeny little bit of flame. I'm going to go out about 4 or 5 inches, and then I'm going to add my air, and I'm going to look for that nice neutral flame. So when you see yellow, that's a dirty flame. You don't want to use that. And when you hear a severely oxidizing flame, you also don't want that. So we're looking for a nice neutral flame, and I'm backing it off to do that. And then this is a pretty big piece of copper, so I'm going to turn my heat up so it gets done a little bit faster. So I'm going to add more gas, and I'm going to add a little bit more air. And then once again, remember the hottest point is at the end of the blue cone there. And so I'm going to come down and I'm going to heat the metal just in one spot. And what I want you guys to notice is the heat transfer through the coloration of this copper. And it may show up in the video, but you will definitely see it when you're doing it yourself. So what I'm hoping that you'll see is that you'll see that it's expanding. And so I'm going to switch to my left hand, which is good to get used to doing. And you can see the coloration that's just spreading. So even though I'm heating right here, copper is sending the heat out, which is why we use copper for electrical wire to transfer electricity. And these colors are really beautiful. They're 500, 600, 700 degrees. So now what I'm going to do is I'm going to come in and I'm going to heat the whole piece. And what I'm looking for is a dull cherry red, which I kind of attribute it to being something that looks like a Bing cherry. And so things turn black. And then what you're going to see, if you're looking at the blue cone, you're not going to see the annealing temperature. What you want to do is look just behind it. And as I'm working here, let me get the heat going. I'm going to start down here, and you can see the annealing temperature right there. And it only stays that way for a couple of seconds. And now I know that this much of the metal is annealed. I'm going to come in and I'm going to keep the flame moving so that I don't melt anything. And now I know I just need to heat across here. So be very methodical and make sure that you're annealing the whole thing evenly so that you can get the pattern, texture, and shape that you want. Do you notice how much hotter it's getting up here? It's transferring the heat. Do you see that bright, bright, bright red? You don't ever really want your metal that hot. Copper's pretty forgiving, but silver will melt into a puddle if you start to get it into those colors. So at this point, I think that's annealed. I'm going to turn the air off first and then the gas, and then I'm going to hang this up right like that so it doesn't fall on the floor. Now this piece I can leave and let cool. One of the things I forgot to mention is if I anneal it laying down flat, it's going to absorb a lot of heat with the fireboard and it's going to take longer. So I like to prop stuff up like this. Kind of reminds me of like when you make a fire, if you've got some airspace in there, it's going to create a better fire. Same thing with the heat on here. I can take this now and I can just let it cool down, or I'm going to quench it into the water. And so when I drop it in here, I'm going to let go and drop it in. If I hang on to it when I drop it in there like this, it's going to crack right where I'm holding it because it's going to cool at a different rate. But now what you can see is these beautiful colors, and you can also see the oxides that are down in the water. That's a sign that I've got this really well annealed. And now I should be able to just be able to bend it with my bare hands. Okay. So what I want you to walk away with is knowing that annealing softens the metal. You have to heat it up to about 1200 degrees Fahrenheit. And then also that if I keep bending this, it's going to start to work harden. So usually in a class, I'll bend it, pass it to a person, have them bend it, and by the time it gets around to the 12 students, the metal is work hardened again. So then what I would have to do is anneal it again. And so that's really the secret, I think, to metal work, is knowing how to anneal the metal and then being able to work it till it gets hard and then know to go and anneal it again. So that's what copper looks like when it's annealed. I'm going to set it aside, and I would like to do one in brass because brass does look a little bit different. It's a yellow color palette instead of a red, so it's a little bit more of an orange red. So I'm going to go ahead and I'm going to open up my gas again. I'm going to strike it. There we go. I'm going to add my air to get that nice neutral flame. Sure. There we go. I'm going to back off the gas a little bit so it's not so hot. And now I'm going to come over, and when I start heating with the brass, it doesn't conduct heat as well, but you can see that it is spreading the heat a little bit here. We're not going to get those gorgeous colors that we do in copper, and you can see that it's moving a lot slower, transmitting the heat. So what I like to do is I like to get in the habit of thinking of my torch as being a paintbrush, and that I'm doing a really good job evenly painting the surface of my metal, and that's going to transfer the heat really well. And it means that I'm going to have even heating, which is a better forming process. So I get this heated up until it starts to turn dark, and now I'm going to start at the bottom, and I'm going to start at the bottom because heat rises. And so I find that it's more economical to start at the bottom and work up. And what I'm starting to get is a little bit of cherry red. And it's a little bit brighter as I'm heating this. And now I've moved up another row. So I almost think of my metal here as being like ruled paper. And I'm just running from one line to the next. And even with brass, I'm going to see that it's heating up faster as I move up, that it is building heat, but not the same in comparison to copper or silver or gold. So I think I talked about it in one of the earlier videos about I classify copper, brass, and bronze as being not as malleable, and that silver, gold, and copper are more malleable. Can you see that red color that's happening right there? That's the annealing temperature. And you could you see some of the little bit of a blue? That's actually the zinc coming off the brass. So you really do want to try to avoid getting too much blue flame. I'm going to pick it up. I'm going to drop it into the water, and when I pull it out, I should have pretty good coloration. You can see that this is slightly warped a little bit, but I'm also having the ability to be able to bend it. Okay. So I do have a piece of nickel silver here. It's going to heat up and work very much like the brass. I would recommend that you get maybe a little piece of it and try it yourself. I think that these two are enough here for you. What I really want to show you now is how to anneal silver. And this is a piece of sterling silver that's 18 gauge. I use a lot of circles in my work, so this is a remnant of that. I left this part on because this is a vulnerable part to melting. And when we start talking about my earrings, when I go to anneal these earrings, I'm gonna have to worry about melting the tips if I'm not careful. Silver doesn't have much color to show you when you're heating it. So one of the things that I do to be safe, if I'm working in an environment like we have here, I can't turn the lights off. If I turn the lights off and we annealed this, you'd see just a really, really faint pink, and that's the annealing temperature. But in these lights, we're not going to see that at all. So what I'm going to do is I'm going to take some of my flux that actually turns clear at about 1100 degrees. So at that point in time, when my flux goes clear, I know that I'm up to the annealing temperature. So I'm going to flux this. It's probably not real clean. We'll see how it goes. But I'm going to use that as kind of a barometer there for the heating process. I really recommend that you practice annealing with the other metals before you jump into silver. Because you can melt it, but the other thing you can do is you can overheat it. And when you overheat it, it becomes hard again. And then you go to work it and it cracks. So it has a much narrower annealing temperature. It's between about 1150 and 1350. Whereas all the other metals, you can go way up the temperatures and not worry about it. So I'm going to come in first. And can you see that this is starting to whiten up? But did you see that it has some spots? I can, after I get it up to a couple hundred degrees, I can just touch down with my paintbrush. And what's happened is now my fingerprints, the grease, is burning off. And now I can put a good coating of flux on my metal. Should have taken this metal and scrubbed it clean, really clean, back by the sink. But I think it's also good to show you guys what happens. But you can see that the flux is just now peeling off. And that's not a good sign. So I'm going to heat this up a little bit more, and I'm going to try one more time to add some flux. See if I can get it to actually stick to it. And if not, I'm going to then stop and clean it. But there we go, it's starting to coat pretty good. Okay, so right now the flux is really thick in some spots and it's kind of balling up. But now can you see that it's flattening out and it's spreading out? And then you can see a little bit of color there, but do you see how nice and flat that flux has become? That's the annealing temperature. And what's interesting about it is the pink that's here is a little bit of the copper that has come up and into the flux that's on there. And that's the way the ceramic artists make their glazes. It's using metal and borax. So I'm going to take this, I'm going to drop it into the water, and I'm going to pull it out. And I can feel that this is pretty nice and smooth here. And then I can see the coloration on here, the back. And this is the copper coming to the surface, and so you'll hear about the dreaded fire scale. If you don't coat your silver very well, you'll end up with the copper coming to the surface that you'll have to sand off. I have a tendency to use a fine silver finish on my work. And so I don't worry about that as much. But I will go into talking a lot more about fire scale and how to correct it. But this won't have any fire scale on it, and this side will. So I'm going to set that one down. I want to anneal these feathers for you. And I'm not going to put flux on these. Because two reasons. One, because I want you to see what the metal looks like when you're heating it up without the flux on it. And then secondly, I have used a Sharpie on here where I'm going to have a line for my design. And when that goes away, that's probably going to be the annealing temperature. That's kind of the new latest thing that people are talking about with how to be able to tell when your metal is annealed, is that you can use a Sharpie on it. I'm not totally convinced that it's real accurate, but we're going to give it a shot here and see. Okay, so I'm going to come in and I'm going to start heating the silver, and it's going to start to turn kind of a orangish goldy color. I remember a guy saying that he had a trade secret on how to make silver look like gold. He was just heating it up until the copper came to the surface. Okay, I'm going to keep heating. Do you notice that I'm not really heating the end very much? Because I don't, now that that's gone, the Sharpie. And you notice I'm keeping moving the torch, and you notice how it's kind of turned black. And that's probably all I need to do. I'm going to drop it into water. I'm going to do the same thing with this one again. So there comes the gold color. That's about 600 degrees. As we keep heating this, the coloration of the Sharpie is gone. And I'm not getting any black coming up on this, but I don't want to go any farther and melt it. I'm going to call that good. And one of the things that I just always recommend is after you get your piece quenched, when you pull it out of the water, is it going to bend easy for you? These are bending pretty good. Sterling is a lot stiffer metal than copper is, but I think that these will be okay for my next step with them. I need now to get these oxides off the metal because they are not part of the metal and they're harder. If I start hammering on it, I'm going to get funny little marks from the oxides. And then if I wanted these to be shiny, I would have a lot of work in the way of sanding them down. So what we like to do is we like to use what's called pickle. And I'm not sure why it's called pickle, except that what we use is sodium bisulfate. And I know that sodium bisulfite is what they use as a pickling agent. I think they're two different things, but let's walk back to the back of the classroom. I'm going to carry these pieces back here. You doing okay, Aaron?
Mm-hmm.
Okay. So this is our pickle pot area. We have it under a hood here because a lot of times we have it plugged in and warm. You never want to boil the sodium bisulfate because it gives off vapors, and those vapors actually rust steel, which is not good in a jewelry studio with all of our good tools. But it's somewhat corrosive. I wear an apron so that if I do spill any on it, the holes are on my apron and not on my good clothes. It's not like battery acid, but it will, if you get it on there and leave it on, it will actually eat your clothes. So it's not something that you want to put your hand in. It's not something that you want to breathe when it's boiling. And so what we have here are copper tongs. And I think each student will have a pair of copper tongs so that we aren't even sharing these tools in the studio. But what I want you to notice is this is a copper and brass, and then we have a silver pickle pot. The reason why I have a silver pickle pot here is because if you take and put steel in the pickle, it's going to copper plate everything. And somebody in the beginning class is going to do that, and then we're going to fix the pickle by changing it, and we'll all learn from that. But that's why we have the copper tongs. And in my studio, I just have one crock pot for all my metals. But here, I really like to have a silver and gold one so that if somebody puts their silver pieces in the pickle, the chance of a beginning student putting steel in here is a lot less. So it's just a safety precaution for the students when you're learning. It's not so bad when your brass comes out copper plated, but it's really sad when your silver comes out copper plated. So I'm going to take these, my silver pieces, I'm going to lift, oops, it's empty. I won't be doing that. I will drop these down in there. Another way you can do it is drop them into this and set it like that so that you have an easier time pulling it out of the pickle. These are both copper and brass, so they can go into either one. I'm going to drop them down in. We have this little basket in here that will allow us to easily get our pieces out. This is going to take 4 or 5 minutes to clean the metal. And when I take it out, I want to make sure that I leave as much of the pickle in the crock pot. And then I don't want to drag this across the counter because I'll put my elbow in it and then my shirt will get ruined. So that's why these bowls are here, to pick up any residue. I'm going to put this back in because it's going to need a little bit of time to pickle and clean, and we'll look at it when it's clean. But that's what these bowls are for. Just as something I do want to share with you guys that's new is that we are now taking our quenching bowls that have the oxides in them, and we're pouring it through this coffee filter to catch all of the copper, because we do not want that copper going down into the sound. And that's something that's relatively new. When I first started in school, we were actually even just dumping the pickle down the drain. You don't want to put pickle down the drain because it's got metal in solution. And then we started realizing, well, those oxides that are coming off in our quenching bowls are copper too. We shouldn't be putting those down the drain. So we filter them and then we put the water down the drain. And so if you guys have questions about how to mix up a pickle, how to get set up at home, I'll help you with that. I do want to say, people come to me and they go, gosh, everything in my studio is rusting. And I go, do you have your pickle pot cover on? Oh no, I don't put the top on. Do you have it heated? Yeah, well that's what's causing the rusting of your tools. So this is not something you want to breathe. It's not something. So in my studio, I actually use a cold pickle. And I'm working on enough projects that I don't worry about it taking 10 minutes instead of 5 minutes. And that's because I'm working in a small space. I'm not worried about all my tools getting rusted and me breathing this, the fumes from it. So it can be used cold and it can be used lukewarm. This is sodium bisulfate. It's a Sparax that you buy from the jewelry supply houses. When I went to Canada, I wasn't able to take any chemicals up there. And so that's when I found out that you can actually use vinegar and salt. That still needs to be processed the same way because it still has metal in solution and you don't want to be dumping it down the drain. It really is cheaper to use the sodium bisulfate than it is the vinegar and salt that's on there. We're going to let those pickle for a little bit, and then we'll come back and we'll show you how to clean them and prep them for the next stage.